Hi everybody, welcome back to the next video in this series. Today we'll be going over some questions from the last topic that we did, sets and Venn diagrams. In future videos, I have thought about changing my approach to tackling different topics. So far, for the last two topics, what I've done is I have made a video in which I go through the theory of the topics, and then I make another video in which I do practice questions. What I'm considering now is changing that and just making one video per topic where I'll be going through the theory and some practice questions as I go along. I just feel like that would be slightly better for you guys as an audience, because then you'll be able to keep track of the flow of the questions and what types of questions you may get from different parts of the topics that we do. So let's begin. Okay, so here we have our first question. In a factory, there are 56 people who work on an assembly line. 47 of them work during the day and 29 work during the night. Now, how many people work both? That just means how many people work during the day as well as during the night. Well, our first approach to a question like this would be to draw out a Venn diagram. So here we have the universal set, which will consist of two Venn diagrams or two circles that will represent workers during the day and workers during the night. So here we have a set for the workers during the day, and we have a set for workers during the night. And now this question implies that there are workers that work both. So let's just call the number of workers that work both night and day. Pardon me, this is supposed to be an N right here, not a W. Let me change that up real quick. Okay, so workers who work during the day and workers who work during the night. Now let's assume that there are a certain number of workers that work both during the day and the night, and we'll refer to them by the letter X. Now we know that 47 workers work during the day. So we know that 47 workers work during the day. But now keep in mind that the number 47 will include the number of workers that work both during the day and the night. So if we were to rewrite this slightly better, we would write it as 47 minus X, because this area right here, this area, I'll highlight it. This area right here represents the workers who work just during the day. And that will be 47, which is the total number of workers during the day, minus the number of workers who work both during the day and the night, which is X. Now, if we repeat that for the number of workers who work during the night, we know 29 people work during the night, so the number of workers who work only at night will be 29 minus X, because X is the number of people who work during the night and during the day. Now here we have an equation. We know that 56 people in total work on the assembly line. So that means that 47 minus X plus X plus 29 minus X should equal 56. So now if we were to just cancel out this X and this X, because that would just give us a 0, that would result in 47 plus 29 minus X equaled 56. Now, if we add 47 and 29 together, we get 76. So 76 minus x equals 56. Now, to solve for x, we would just add x to both sides, so we get rid of the x on the left-hand side, and we get the x on the right-hand side. So this would just become 76 equals 56 plus x, and then we would subtract 56 from both sides to get x equals something. So if we were to just subtract 56 from both sides, we would get 76 minus 56 equals x, and that leaves x as 20, so therefore x equals 20. Now x represents the number of people who work both during the day and during the night. So now we know that the number of people who work during the day and during the night is 20. The approach to tackling problems like this is to assign a variable to one of the unknown values and then work your way through the problem to get every other value in terms of that unknown value wherever applicable. So in this instant, the unknown value was the number of workers who work both during the day and during the night. So that meant that we had to convert the number of workers who work just during the day from 47 to 47 minus x using the unknown variable, and same for the night. And then we were able to equate them together to get a value of x, of the unknown variable that we were searching for. I hope this was clear, and let's move on to the next question. Okay, so for this question, we have to represent these two equations on a number line. And if you may remember, these are written out in bracket notation. If you do not remember what bracket notation is, please check out my last video where I talked about it in quite a bit of detail. Okay, so first we need a number line to showcase these values of x on. So I'll just draw a number line right here for the first question. And let's give it a bunch of values. You have 0, 1, 0, 2, 4, 6, then -2, -4, and so on. And then we'll just add these little arrows here to show that this number line is just expanding towards infinity on both sides. Okay, now if we look at the equation that we have over here, it says that x is within the range from -infinity towards 3. Now if you remember, whenever we have a bracket with infinity, it will always face away from infinity. So that means it will just be coming out from the negative side here. And because we have the 3 here, it will stop right here. This will be our point. And keep in mind that because the bracket here is facing away from 3, that would mean that we need to keep an open circle here, or a hollow circle that is not filled in, because it represents that the value 3 itself is not included within the possible values of x. So now, because it's coming in from -infinity, it would just be this. And this spot here is 3. This is how we would represent the first equation. This shows that x is within the ranges from -infinity, so x can be anything back here, all the way up to, but not including 3, which is why we represented it with a hollow circle. Okay, next we have a slightly harder version of the previous equation. Here we have 2 different possible values of x, which is from -infinity all the way up to, but not including 2. We have the outward facing bracket here from 2. meaning that 2 is not included, and that is unioned with all the values of x that are from 5 up to 8, but not including 8. Note here that because the bracket is inside or towards or facing 5, 5 will be included in the possible values of x for the second part here. So for the union, we would first have to draw out the individual lines. Again, if you were answering this question on a test paper, you could do it straight away, but I'm just going to draw it out for you so it is easy to understand. I might have to edit out the values on the number line because this goes up to 8. Okay, so here we have a number line up from negative infinity to positive infinity, and now on this one we can actually draw out our numbers or our ranges. So let's begin. Firstly, we have the first half, which comes from negative infinity all the way up to 2. So let's draw a circle here because it's up to but not including 2. It's negative infinity, so it extends all the way back to negative infinity. Next, we have all the values of x that go from 5 to 8. So 5 would be somewhere here. And because it is including 5, I will fill this in. 5. And then 8 is here. And 8 will get an empty circle because it is not including 8. And I'll join these two. And there you have it. Because this is a union, all the numbers that are represented by this entire equation will be anything from negative infinity up to 2, but not including 2, and between 5 and 8, including 5, excluding 8. Let's move on to the next question. Okay, so for this final question, the only thing we have to do is we have to be able to represent this diagram here using set notation. Okay, so if I were to redraw this out slightly bigger. Okay, so I'm no artist, but I try to draw this as accurately as I could. So now if we look here, what we see is that the entire set of A is shaded in, but the subset of A, B, is not shaded in. So one way, and the only way we could represent this, is we would look at A first. It is A, and then in what circumstances would B not be shaded in? And that would only be possible when you have B complement. So B complement. And now if we look about it, if we were to shade in A, that would mean the entire thing was shaded in. And that would include parts of B as well. But because we also have B complement, which would be everything other than B, the only parts that would interact and intersect, that would form this image up here, would be when we have an intersection of A and B complement. Think about it. When you select A, which is everything inside A, and you intersect it and find whatever common part it shares with everything outside of B, you would get this shape up here, A complement B. A intersect B complement. I hope that makes it clear. And there you have it. This was the second video for the sets and Venn diagrams, and in this video we went over a few practice questions. If you have any questions or any feedback, please feel free to leave it in the comment below, and I will get back to you ASAP. In the next video, and in other future videos, I'll make sure to add questions as we go through the theory itself. it should help with your flow and your understanding of the math concepts, because you'll be applying what you learn immediately to a problem. And I think that helps it settle in a bit easier. So I hope you enjoyed this quick video, and see you later. Thank you.